Hello everybody, my name is Shanti Srinivas and I am a postgraduate in chemistry from India. I worked as a science teacher in India and then as an IT network manager in the UK. In 2019, I completed the Masters in Sustainability in Energy Provision and Demand Management from the Centre for Alternative Technology in Wales, which is when I became interested in retrofitting existing buildings with natural materials with low embodied energy. This led me to apply to ERBE to join their PhD studentship last year. My pilot study seeks to answer this question. Can passive air conditioning strategies regulate indoor temperature and relative humidity, thereby improving thermal comfort and reducing energy demand in apartments in Bangalore, India? India's residential sector was responsible for 24% of India's total electricity consumption in 2016 and will be responsible for a quarter of the total global energy demand by 2040, with energy consumption predicted to rise by more than 8 times by 2050. Majority of the existing residential buildings are made of concrete and cement and steel. It is predicted that India's middle-income group will be responsible for the increased electricity consumption with multiple air conditioners in their homes for cooling. The economically weaker section of society, who can only afford fans for cooling, will bear the brunt of the discomfort due to the increasing temperatures and power cuts. Improving thermal comfort by passive means and reducing active cooling energy demand is therefore a priority for India. India's Bureau of Energy Efficiency found that there is between 30 to 50% energy savings potential from building envelope upgrades. Upgrading the envelope and making the building more airtight will reduce heat transfer but will also affect moisture transfer as they are coupled processes. There is a need for pilot projects to study ventilation and hygrothermal performance of buildings insulated with natural materials like straw, according to the study by Sabapathy and Gedupudi in 2020. No pilot projects or studies involving hygrothermal simulations, case study building retrofit, and on-site data monitoring pre and post retrofit have been done based in Bengaluru. My pilot study involved hygrothermal parametric simulations of passive envelope strategies on an apartment in Bengaluru to analyze thermal comfort only. A very limited number of strategies and parameters identified by literature review were simulated. Simulated data was analyzed using MS Excel and found that all strategies improved thermal comfort over the whole year. Natural ventilation and shading improved thermal comfort during every month of the year, while the other strategies were more effective during some months but not in others. The PhD study will study these and other strategies with more parameters and in more detail, and will analyze both thermal comfort and energy demand using Python and involve future climate analysis too. 8 days of on-site temperature and relative humidity logging was carried out in the pilot study. The PhD study will involve a year's pre-retrofit and post-retrofit on-site data monitoring. Data loggers are monitoring temperature and relative humidity in the bedrooms and the lounge of one case study building. I am currently working on an occupant questionnaire and building survey to understand the occupant's perception of comfort and energy use in the building and gather as much accurate data as possible about the apartment and schedules for occupancy and window opening and internal and heat and moisture sources. The next 6 months will involve carrying out computational fluid dynamics simulations, shading analysis, and hygrothermal modeling and simulations. This will be followed by 6 months of simulated and monitored data analysis using Python. Installation of passive retrofit measures on the case study building will be followed by post-retrofit data monitoring. I will also be simultaneously running hygrothermal simulations with future climate files. I would be interested in collaborating with anyone who has experience with using computational fluid dynamics simulation software like SimScale to optimize natural ventilation, using Suncast or similar software for shading analysis, or using Python for data analysis, as there's going to be a lot of data to analyze. Thank you. My email address is below.